Hi friends, this is Miss Hass. Here's Lucas doing a little floss to get us started. All right, you little stinker, go to bed. Can you do anything else? You want to do another dance for him? Excellent work. Okay, give me a kiss. Love you. Go to bed. Mom's gonna work on her video. Nope.
I see both of the pictures.
Nope, you'll have to watch it another time. Go to bed. All right, friends, here we go. Let's do some math. I thought that would be a fun way to start out. He was supposed to be in bed, but he just came out to see what I was doing instead of going to bed like he's supposed to. And so I thought, let's see if we can start it off with a fun floss. Okay. I don't know if you can see this. All right, here we go. I might have to adjust that. I don't know if I like it. All right, so here we go. Page 1 of our Mod 5 review. And the first question is wrong. Little typo. So this equation and graph do not match. I don't know. I know a few people noticed it. This should say, let's do this. This right here should say +2. Because the graph is a parabola that's been shifted up 2. So that's what it should be. That loud banging you hear, you're going to hear a lot. That's my dog playing with his ginormous bone. Okay, so let's see. We're just supposed to find the domain and range of the following functions. So if you're looking at this one, remember you want to put your finger on the x-axis and ask yourself, is graph happening? I'm assuming we want you to assume that those have arrows and keep going. So this is going to be graph happening, yes, 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 all the way across. So this is negative infinity to infinity. The range of the graph, that means you put your finger on the y-axis and you start at the bottom and you go up and you go, is graph happening? Nope, 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 nope. Yes, 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 yes. So this is going to be +2 to infinity. So that's what you should have on the domain and range on that one. And let's see, how are we going to do this part of it? I guess like that. Oh, too big. Nope, too small. Okay. Something like that. Okay, so now this one, domain and range. Put your finger on the x-axis. Is graph happening? No, 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 no. Yes, 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 yes. No, 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 no. So that happened from -2, including -2, so bracket, all the way to 2, bracket. Same question, is graph happening? Put your finger on the y-axis for the range. Is graph happening? No, 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 no. Yes, 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 yes. No, 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 no. So that's going to be from -3 up to 3 and everything in between. And then we're going to use brackets to show that the -3 and 3 are included. And that is the graph of an oval. Okay, so now let's go down here to number 3. Let's see if I can fit that on our little screen here. Directions say find the domain of the following functions, use a number line analysis and write your answer in interval notation. Okay, so notice we're only asking you for domain here, not domain and range. That's because usually we're not going to ask you about the range unless you've got a graph to look at. So this is just the domain. Anytime you have a fraction with a denominator that could be 0 or a radical that could be negative, has a variable underneath it that could be negative, you have to be careful and limit your domain. So we are looking right here at the denominator. We don't care about the denominator when we're talking about domain. We care about the denominator for other reasons, but not with respect to the domain. So I am going to take my denominator and set it equal to 0. And let's see, solve or simplify it, factor it is what I'm trying to say. So I'm going to do that. And then the -8, remember 8 could be a 1 and an 8 or a 2 and a 4, and it looks like it's going to be the 2 and the 4 option. I want that to be negative and that one to be positive. Does that give me my -8? Yes, it does. Does it give me my -2x? If I check here, that gives me a 2x and that gives me a -4x, so that does work. So that means that x equals -2 or x equals 4, but actually that's what we don't want x to equal. We don't want it to be a -2 and we don't want it to be a 4, because if it's either of those two things and I substitute it in up there, I end up getting a 0 for my denominator. So those are my exclusions actually. So this is the number line analysis part. So come down here and I'm going to put a -2 and a 4. I don't worry about how good my spacing or bad my spacing is. put an open circle. Those are the two values it can't be, because we've just figured out that's what would make the denominator equal 0. That means x can be anything else but not -2 or 4. So there's my number line, and here's going to be my actual domain. I'm going to read this from left to right. So starting way out here at -infinity to -2, and then I have to stop at -2, and basically jump to the other side of it and go -2 all the way to 4. Then basically jump to the other side of 4 and go 4 all the way to infinity. Like that. Okay. Anything exciting about that? No, I think that's about it. Okay, so now we're going to do the same thing. So the other time, besides when you're dealing with a fraction and a denominator, the other time that you run into issues is when you've got a radical. You don't want what's underneath the radical to be a negative. X itself can be negative. What's underneath the radical overall cannot be negative. So I want x plus 5 to be greater than or equal to 0. That means it'll be 0 or positive. So I'm going to subtract 5 from both sides, and I get x is greater than or equal to -5, Miss Haas. Oh, God, I hope I don't make a bunch of mistakes on this one. Okay. I am tired, though, and it is late at night, which doesn't bode well for you guys. So you can keep track of my mistakes and let me know tomorrow. Okay, that'd be great. Okay, number line analysis is blah. Here's -5. It can be -5, so it's a closed circle. And then this says all my x's are bigger. Alligator mouth is eating x, so it's bigger than -5, so that's this way. Okay, cool. And then now that's going to be -5 to infinity. I'm just going to double check my work. Subtract 5 over. I did. That is true. True dat, true dat. Okay, cool. So those are domain problems. And now what are we looking at? Number 5. Find the following composition of functions. So we've got, oh, why are we so crooked? Maybe that's better. Let's see. Find the following composition of functions given f and g. So this says f of g of x. F of g of x. That means g is going to be inside of f. So I am going to go get my f function. F is on the outside, so I'm going to go get my f function. And it's 6x minus 2. Notice I said x, but I didn't write an x. I wrote parentheses. Now I'm going to take g and substitute it into that. So this is 3x plus 7. And now it's just simplifying. Distributive property is 18x plus 42 minus 2. 18x plus 40. Okay. That one's good. Now, this is a different notation, but it means the same thing. Well, it doesn't mean the same thing. It's a composition. These are both different ways of saying composition. This one is called GOF, or G of f of x. So as you guys know, I don't love writing it like this. I prefer to see it like that. Order does make a difference. If G is first, then F is inside G. If F is first, then G is inside F. Okay, so now it says G, so I'm going to go grab my G function, 3x plus 7, and then I'm going to put F inside of that. So that's 6x minus 2. This is 18x minus 6 plus 7. 18x plus 1. I'm going to double check my math. 18x minus 6 and not, that's just a 7, blah, 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 blah. Okay. Box them up. Please box your answers on the test. It's really hard to figure out what your answers are. I'm not here to figure that out. Okay, I'm going to stop this recording and start another one so that they're by page. Okay, bye-bye. See you in 1 minute.